Hello all. In today's video, we are going to learn about the Transmission Control Protocol or the TCP protocol of the transport layer. The Transmission Control Protocol is a connection-oriented, reliable process-to-process protocol of the transport layer. If you remember, the IP protocol of the network layer was called as a best effort delivery protocol, which would only provide delivery of packets from host to host. But it did not guarantee the reliable delivery of packets. The feature of reliability was missing in IP protocol. It was the job of the layers above the network layer to provide those services. And that reliability is being provided by the TCP protocol. So you underline this. TCP adds connection-oriented and reliability features to the services of the IP protocol. What are those services that TCP provides to the processes at the application layer? Process-to-process communication. The transport layer is responsible for communication or delivery of packets from process to process using the well-known port numbers. It provides full duplex communication. What do you mean by full duplex communication? We have learnt about modes of communication in Unit 1 about simplex, half duplex and full duplex. In full duplex communication, the data can flow in both the directions at the same time. So TCP offers the full duplex communication where to provide this full duplex communication, it makes use of sending and receiving buffers, where the segments can move in both the directions, which we will learn. Connection oriented service. Now, as I told you that TCP is a connection oriented protocol, meaning whenever processes will communicate or whenever there is delivery of packets between the processes, a particular connection is being established between the source and the destination. A virtual connection is established, then the data transfer will take place. Once the data transfer is completed, the connection is terminated. So these are the three steps that we do when we want to communicate. Connection is established, data transfer takes place, and connection is terminated. Then the next service it provides is, it provides reliable services. Reliable service in the sense it will provide error control, it will provide flow control, error control using checksum, it provides error control using retransmission of lost or corrupted packets, it provides acknowledgement policies and timers. It also uses the features like byte number and sequence numbers and acknowledgement numbers to ensure reliability. Then it offers stream delivery services, meaning it will deliver a stream of bytes and later the stream of bytes will be will be grouped into segments. Then, as I told you that it provides full duplex communication, and to ensure that you have full duplex communication provided by TCP, we require sending and receiving buffers at the source and the destination machine. So the TCP needs buffers for storage because the sending processes and the receiving processes may not work on the same speed, or they may not read or write at the same speed. So the data has to be temporarily stored in a buffer at the sending side as well as at the receiving side. That is why we call them as sending buffers and receiving buffers. Basically, the buffers are implemented using a circular array where each location in the array carries 1 byte of information. Let me show you this with a diagram. The sending process maintains a sender buffer and a receiving process maintains a receiving buffer. The buffer is basically a circular array where one location specifies 1 byte of information. Then we have, as I told you, the stream of bytes will be grouped into segments where every segment will have the data and the header along with it. And then we have this coloring scheme tells you that how many segments have been sent, how many are yet to be sent, how many are being sent but not yet acknowledged. All this information will be there in these, can be known through these buffers, both at the sending side and at the receiving side. Now, as I told you that we are dividing or grouping that stream into segments. So every segment consists of the header and the data. So we will learn about the segment format now. In UDP, we called it as a user datagram. Here we will call it as TCP segment. So a packet in UDP is a user datagram, but a packet in TCP is called as a segment. A segment comes in two parts consisting of the header and the data. The header size is variable. It can be as slow as 20 bytes and as large as 60 bytes. When there are no extra options available in the header size will be 20 bytes. When there are options, then it can vary up to 60 bytes. Let us see the segment format of TCP. We require a source port address and a destination port address to identify the processes on the source machine and the destination machine. We require the source port address and the destination port address. As you all know, a port number is 16-bit integer, so 16-bit long, so we have specified it as 16 bits and 16 bits. Then comes the sequence number. What is the sequence number? Sequence number is a 32-bit field which is used to define the first byte of data contained in the segment. That means if you have a segment and the segment consists of number of bytes of information. So it gives you the sequence number of first byte in the segment. And as you increment the sequence number, you can get the sequence number of the following bytes. Acknowledgement number. Acknowledgement number, as I told you, the acknowledgement number, when we were learning about data link layer protocols, the acknowledgement number defines the byte number that the receiver is expecting to receive. This field defines the byte number that the receiver of the segment is expecting to receive from the other party. And basically, if you remember, the acknowledgement and data are piggybacked together. I told you about piggybacking. Piggybacking is a concept where we will put the acknowledgement of a particular frame in the data packet itself. That is called as piggybacking, where the acknowledgement will get a free ride in the data frame. Then we have the header length. The header length is of 4 bits. That means I can have a header length of, if the value of the header is 5, 4-bit field, 5 4s are 20. The size will be 20. If the value of the header field is 15, it is 15 into 4, 60 bytes long. Then we have these 6 bits reserved for future use. And then we have a set of control flags which we will be learning. Then we have a window size. The window size specifies the size of the window in bytes that the other party must maintain. That means what is your receiving window size, which is basically determined by the receiver. Then we have the checksum field. The checksum field is used for error detection. The checksum field in TCP is mandatory. Then comes the urgent pointer. Now this is interesting. The urgent pointer is a number when basically used when the urgent flag here is set to 1. When this flag is set to 1, it means that the segment is consisting of some data which is urgent data, meaning sensitive data which has to be delivered fast. Okay, so now this, how do I reach to that urgent data? If this urgent pointer number is added to the sequence number, we reach to the end of the urgent byte. You can see here, the urgent pointer is valid only when the urgent flag is set to 1. It basically contains urgent data. The segment basically, when it contains urgent data, the urgent flag is set to 1. This basically is a number that must be added to the sequence number so that we can obtain the urgent byte in the data section. Then we have the option field, which is optional. Okay. And let us talk about the control flags now. Here we have control flag called as urgent, which is equals to 1 when we have urgent data in the segment. Then we have a flag called as acknowledgement, where when you are receiving an acknowledgement, this flag will be set to 1. The push flag PSH is equals to 1. When if this flag is set, it means that we are pushing the data onto the connection. RST, reset, when this value is equals to 1, that means we are resetting the connection. We have a flag called as SYN, synchronize. When you would like to synchronize between this sending and receiving device in a connection, then you will send the SYN flag is set to 1 when you want to synchronize the sequence numbers. Then FIN flag, that is the finish flag. When you want to terminate the connection, the finish flag will be set to 1. So these are all the control flags of your segment, TCP segment format. So in this video, we have learnt about the TCP protocol, the services it provides, and the TCP segment format. Thank you.